Perfect. Okay, so it's 9 o'clock. Let's start on time. Let people join in. And I'm super excited to host today's session. The reason why I'm doing this session, I will be very frank with you. Okay, I'll be introducing myself. Don't worry, because many of you may be knowing me, but many of you may or may not know me at all. So I'll start with a simple introduction. But before that, I will just clear one simple thing, which is why I'm doing this session. The simple reason why I'm doing this session is we are working on a project for electric three-wheeler in India right now. Okay, we already worked on 3 or 4 projects as Eleno Energy LLP. Okay, that's our company name. So I'm a partner in that company. My other partner, Mr. Mayur Kulkarni, sits in US. We have a US operations as well, United States of America operations as well, which is Eleno Engineering LLC. So what happened is this electric three-wheeler company is actually looking for a design solution, but at a very fast pace. Reason, they have very limited resources as far as designers are concerned. So what happened is CAE simulations, the first simulation which came out, or the results which came out, we came to know that there is tremendous need of improvement with regards to CAD overall design. And that particular thing triggered few important points, or that triggered this particular session actually. So what happened is we designed most of the parts using LSDYNA or using static or dynamic analysis. We didn't design them first and then did the simulation. We had a basic structure, and based on that basic structure, we did our load cases. I will be explaining you various load cases, some categories. And what happened is it came to our mind and understanding that it's pretty easy and it is very effective because it saves a lot of efforts in creating CAD models. So what we did is there was a commercial vehicle which was bus. So if I could share that screen, I'll just try and check with my non-disclosure agreements and other bit, but at least I can draw some figures. Don't worry. OK, so there will not be too much of a data sharing with regards to customer data. That's very confidential. So we don't want to breach any of the trust factor for that particular purpose. But the thing is, design using CAE is going to be new standard for everyone, not just for electric vehicles, not just for defense, not just for regular automotive giants. It is going to be for everyone. And if we are going to do, or if we are going to look at it in a better perspective, we will be in a position to design something right at first time. OK, something right at first time. That's what the intention is. OK, that's what caused me to have this webinar with all of you, those who are enthusiasts. My intention is this gets recorded. I'm recording it right now, as you know. This gets documented. So whatever are my wild thoughts, they are not going to just go anywhere haphazard. So I just want to document them. That's one purpose. The other purpose is you guys get some information, some additional information. I'll not say this as an extensive CAE session or a CAD session. It's a mechanical engineers session where we will try and understand how the CAE makes lesser iterations at the design side. OK, so let me introduce myself. I'm Nachiket Phadke. I am from Pune, city of Pune. It is western part of India, very nearby to Mumbai, which is financial capital of India. This is a big city now, and it's an automobile design hub. The manufacturing capacity is less, but there are maximum number of design organizations, simulation organizations, and testing organizations in Pune. And we serve a lot of defense institutes here in Pune. There are many defense institutes, defense establishments. The airport of Pune city is actually run by Indian Air Force. It is not a civilian airport, but they allow civilian aircrafts to land. That's how important Pune is geographically. And I started my career as graduate engineering trainee back in 2005, uh, almost 17 years now. And I started working on Unigraphics for not more than 2 or 3 months. And then I shifted in the same organization. I got a shift to computer aided engineering department. Back then, LSDYNA was pretty new, to be very frank. Back then, Hypermesh was pretty new. People were using it for 5, 6, 10 years, but not more than that, and at a very limited capacity. So I started working on seating system projects. Company name was Tata Johnson Control Limited. It was a TACO and Johnson Control joint venture, which was a typical case back then. There was Tata Hendrickson, there was Tata Hitachi, there was Tata Ficosa, all these Tata Yazaki, all these Tata Faurecia, all these joint ventures were there. And one of the joint venture was Tata Johnson Control. So Tata is a big group, all you know. And I worked there for 8 years. I was there in Germany through Tata Johnson Control itself. I was there in US through Tata Johnson Control itself. I came back, served another 1 year or so, but always wanted to start my own company, my own organization. Where to start was an issue. Again, I switched to one more organization called Shape Corporation. It's all there on my LinkedIn, but I'll just still put it in front of you. So Shape Corporation is more into bumper systems. They are our esteemed customers now. But in Shape Corporation, we used to deal with ECR42, slow speed impact, high speed impacts, and other bit. And this is all going on well. I was a CAE head back then, 2012, 2013. I quit the organization and I started my training institute. So training is still my passion. The most important thing in my life, which I admire most, is I can train. To be very frank, reason not because I earn money by training. Reason I can inspire few more people to stick to basics of engineering and stick to core engineering field in the overall havoc of startup boom and app based services and aggregators and other bit. Okay, so the real design I really want everyone to concentrate on. And that's what I'm doing for many years, almost now 20. Now this is going to be my 10th year. 2023 will be 10th year in my in the training business. And I'm doing Hypermesh LSDYNA training, but I'm not doing tool training. I'm doing more of a crashworthiness analysis training holistically. And at the same time, we have a parallel organization, which is L&O Energy LLP, which is more into engineering services. So training part is entirely different vertical. Engineering services is an entirely different vertical. The licensing is also different. The work environment is also different. Thanks to pandemic, I'm the only employee now in my training institute. Whereas earlier, when I started, I grew almost to 10 employees in the training institute itself. There were trainers, there were instructors, but all of them I converted them to engineering professionals now, and they are no more trainers. So they are doing their own work, which is typically defense or railways or automotive or space related or aerospace related stuff. OK, that's it from my side. That's the only introduction part I wanted to put forward. Now let's come to design using CAE and specific to electric vehicles. OK, so what is happening? What are the various things which are going on? And what is it that we faced while designing electric vehicles? OK, so at L&O Energy LLP, we have contributed a little bit on electric bus, 8-meter and 12-meter length for a UK based leading bus manufacturer. We are currently working on an electric three-wheeler. We did work on almost 4 or 5 electric three-wheeler chassis optimization, and that was a very good experience for us because electric three-wheeler is the fastest going electric vehicle market in India. Okay, not even electric two-wheelers. Electric three-wheelers is the fastest growing market. The surprising fact is last month, which is month of May, in India, electric three-wheeler sale surpassed the conventional IC engine three-wheeler sale. And that's something which is a good achievement, which is a good direction. because typically electric vehicles or these three-wheelers typically run in the city boundaries. They don't go intercity and they don't spend more than 100 kilometers per day. They are more of a pick and drop and delivery kind of a services. So electric three-wheelers is the best way to move forward. So I'm more focusing on electric three-wheelers at the start of the session. The second part is buses, which is again point-to-point direction. So I'm very proud my ex-partner Milind Kulkarni, he designed, developed and did a prototype of electric intercity bus, which was Shivai. I was part of Citrin Engineering long back, almost 10 years ago. But he's a good friend of mine, and he did a commendable job in getting state transports to build their own electric buses. So that is what is happening. Electric two-wheelers, you all know there is a lot of buzz and everything going on because it's a consumer product, but these are more of a B2B products. So they don't get too much of a talk. And the third market is passenger vehicles. Nexon is beating every single bit here and there, Nexon and the Tigor electric. And then there is a small stake of MG, small stake of Hyundai. But there will be more players who are going to come down in passenger vehicle market. And then there is one more segment which is off-highway vehicles. JCB is trying hard, but they are trying more on a hydrogen fueled engines or hydrogen fuel cell vehicles rather than battery. As you know, they need tremendous amount of torque and energy. So maybe electric powertrain or a battery powertrain may not be too much of a suitable thing for them. The third thing is material handling, or fourth one, material handling. Forklifts are now getting converted to electric very fast. They are driven by electric motors, to be very frank. There is a diesel engine which actually generates electricity and the electric motors drive it, or hydraulic motors drive it. So it's not actually directly driven by diesel engine anyway. And due to environmental hazards, the operational hazards, it cannot emit too much of a smoke inside the factory. So forklifts are getting converted. Some small tug vehicles are getting converted to electric. Due to metro boom, every single city, big city in India now is getting ready for a metro transport system, fast transport system. There are feeder services which are in the range of 1 kilometer, and this is all happening again with electric three-wheelers for a bigger transport or bigger chunk of a transport, but at a very what you can say short distance and higher frequency. So this is all to give you an idea why exactly it is important to have a design angle for a CAE engineer. Okay, what is happening? We only do simulations. If you are a CAE analyst, we only do simulations given on a given CAD. Based on a given, let's say there will be a load, there will be some kind of a regulation, but that's all. We really don't focus more on anything. So it is happening that a design engineer has to become or has to make himself or herself ready for CAE. That's a reality. Okay, so if you are at a very young age, it's perfectly fine to focus yourself on a CAE side. At the same time, when you are working in your organization, when you are doing a CAD thing. Okay, so let me share a screen. Okay, guys, are you with me? Is it little bit of an interest? Type in interesting if this is interesting. Just type in I so that I can know. I think chat box is enabled for everyone. Just type in I interesting if this is interesting. I'm just looking at the chat box. Yeah. Thanks everyone. Okay, so I'm giving market perspective because that is something which is lacking when I interview engineers. They really lack a lot of things with regards to market. They just get disconnected from market. They are more focused on the academic side, the tool side. But why we are using tools? We are using tools to develop product. And what is a product? Product is something which is used by either a consumer or by someone who is really going to use it. And that is something which is missing. So I feel little bad. So get connected, talk to or look at some of the videos, look at some of the important magazines, articles and other bit. OK, so this is one important slide. I'll just share with you guys. Yeah, there you go. Just type in V if this slide is visible. This is generic. OK, this is nothing to do with any customer. So this is a very generic slide. Just type in V if it is visible, right? Okay. So I'm sharing entire program, which is the PowerPoint presentation. But what happened? It is gone. Okay, I'll stop sharing and reshare again. 1 second, guys. Not visible, right? Yeah, that's what something happened and it just snapped. So okay, I'm sharing entire screen of mine now. Is it visible? Perfect. Yep. Okay. So still, I think this particular slide went away, but side crash calculations. Let's close it off. Save. Oh, that's fine. Yes. So let's talk about little bit about EV classification. Okay, what is exactly happening in EV space? I'm not an expert in EV, to be very frank. I'm just trying to get you through some important things, and let's talk about EV in a little bit of a logical sense. Okay, so as I said, there is going to be commercial vehicle division or commercial vehicle part, and there is going to be a passenger vehicle part. Now, when we talk about commercial vehicles, as I said, there will be buses, there will be three-wheelers, and there will be that's all. We will just stick to this. Passenger vehicle, there will be two-wheelers and there will be cars. So this is a typical classification, a generic classification. Now, as I said, this three-wheeler market, electric three-wheeler market is the fastest growing one right now, entire world. Okay, and that there is a reason. There is inherent disadvantage of range and anxiety about range when we use electric three-wheelers or electric vehicle as a whole. And if you are going to not going to travel more than 150 kilometers in a day or 100 kilometers in a day, you are pretty much clear that range is not going to matter most. So that is where this is going on. This is also booming. The second one, cars is going on, but I will say it is little slow. Reason being, individuals do have cars and they don't want to get rid of it. And if they want to occasionally travel intercity, it becomes a little difficult in developing nation like India to find a fast charger and other bit. So the charging infrastructure creates an anxiety. So cars are moving at a slow pace, but buses are also there moving at their own speed. Reason buses are not owned by two big businesses. They are typically owned by government itself. Okay. So what is happening, guys? There is serious amount of product development which is needed. Okay, so what used to happen earlier, the product was getting developed somewhere else and that product was being sold somewhere else. Now what is happening, you have a product which is getting developed for a specific need, and those needs are specific to the local region, those needs are specific to the local areas, and that is where this entire product development cycle crunching comes into picture. So let's get closer to product development cycle. We have concept phase. Okay, the concept have something which is out of your own mind and you are just coming in and joining in or doing something. It will come, the consumer will give some or the other hint. Okay, and that is very important. So consumer is going to drive a concept. The concept department is going to be focusing on shape. They will focus on size of the product, and they will also focus on the material, that is user experience. So how you want this pen to feel? Okay, do you want it to be a plasticky feel or do you want it to be an aluminum satin feel? That all depends on how you want your customer to experience your product. Okay, so this entire concept thing is not driven by engineering. It is more driven by human factors. That is senses. How you feel, how you smell, how you see, how you touch. All these things are going to be dependent on human senses. Okay, but while you convert it to an engineering product, this concept into an engineering product, you need three important departments. And I'm talking about not the mass production. I'm talking about just the prototype. So you will have a design department, which is an engineering design department. So they will take clue of shape and size. They will try to find out ways of manufacturing it in that particular shape or in that particular size. They will check for whether the material which is suggested by the concept department is possible to be put in or not. And then it is all going to come to the engineering part. Okay, which is CAE part, which is virtual validation. Okay, so this is something where you have entire list of things to do. So what are the various things which CAE can do, CAE department can handle? So CAE can handle a finite element method code, and it will do a structural analysis. Again, in structural, you will be doing some kind of, let's say, crash. You will be doing static load. You will be also doing fatigue. You will be doing durability, and you will be also doing NVH, noise, vibration, harshness. So this CAE department will have an FEM team which is going to do all these things. Then this CAE department will have a CFD team which is going to do drag analysis, coefficient of drag. Then they will do some flow related stuff. All these things, heating, cooling, thermal analysis. Okay, everything is going to move forward like this. Make sense? Okay, so we have a CAE department which is going to have FEM, CFD. There will be discrete element methods, SPH and other bit, but not for the automotive side, to be very frank. It will be more on a defense and the other bit, let's say more on a defense and railways and those guys to SPH, which is sloshing, especially tank sloshing, and you go into a dip, you go into a water tank, you drive vehicle for, let's say, 600mm height, and you see the splash analysis. How much is the drag? Whether the vehicle will be dragged on the left or on the right due to a sudden entry into the into a dip. So this is all being type is what? By definition, it is 1:1 working model. Okay, prototype is 1:1 working model, so it must work and it has to be 1:1. So you cannot have something just like a mock-up. It has to be working, and you cannot have it working but at a scale version. So you cannot have it smaller. You have to have it 1:1 and it should work. So a prototype development needs a lot of inputs from CAE, whether it is all going well, whether you need some improvements, all these things. Okay, so always remember, guys, a concept phase and an engineering design phase are always going to talk to each other. Okay, our concept guys and design guys. Similarly, the engineering designers and CAE and prototype, and of course design and prototype, all are going to talk to each other in an organization where product is getting developed. So there is a thin line when you enter into a product company, that this is a dedicated CAE guy, this is a dedicated CAD guy, and this is a dedicated proto guy. When I'm talking about little bit of a senior level, what happens is everyone must understand every single's responsibility and every single's role. Okay, so this is something which is happening in a product company. Let's say electric through two-wheeler company or a three-wheeler company or a four-wheeler company or anyone, not just electric, for anyone. But why electric? Because there are more startups in electric field than in ICE engine side, because there is tremendous thing which happens for a supply chain when it comes to ICE engine. The engine itself is too critical. So it becomes easy for these guys to enter into this space because the motor development is not that difficult as compared to the ICE engine development. Okay, so a product company will always have a CAE department which is going to talk to CAD department. Now what happened? I'll just explain you a scenario. Company name, I'll name this company as X. Okay, company name is X, and they're developing an electric three-wheeler with chassis which looks like this. Okay, and there is this is the area where the front wheels will be, and this is the area where the rear wheels will be, and there is going to be this kind of a angle or this kind of a rake angle for the steering. Okay, basically it's a handle. The steering is nothing but a handle. So what is happening when there is a single wheel bump? That means you go into a ditch, a small, maybe a small ditch, a 3-inch, 4-inch, 3 to 4 inches, or not more than 100 millimeter. I'll call it. Okay, about 100 millimeter. So what is happening as you go into that particular ditch? There is going to be a bending which is happening between this chassis and the steering column connection. Okay, so I'll call it as steering column. And this is not actually being seen in a pure static case. Okay, so we all know pure static case, if you try and convert if you try and convert any dynamic load into a static equivalent, you may not get the similar results when it comes to reality. And the prototypes used to fail. So that was coming back to us as an inquiry why this is happening. So the shock load, we should not do a static case in this particular scenario. We will be doing a dynamic load, a pure dynamic time domain load, which will be a shock one. And it will be in 10 milliseconds or maybe 20 milliseconds, and you have to apply that particular shock, or you may have to create an actual impact. Okay, again, this is time domain. So if this is a time domain thing which is happening, what is happening? I'm not actually designing using hand calculations. I'm designing using what are the CAE results, what is the bending force or bending moment which is coming up, and what are the cross-sectional forces, so that I can design my moment of inertia in such a way that it absorbs this kind of a bending. Is this making sense, guys? Type in MS if this is making sense. Okay, just to understand whether you have understood it or not. Is it making sense? Okay, MS, correct. Okay, so this is what is happening. I'll just stop sharing. I would like to have a small discussion with you over chat. Okay. So Suraj, you are not able to see my screen. You are not able to see. I'm really sorry. I missed the chat. But you were able to see my screen, right? Okay, so guys, what we discussed right now is one scenario of design using CAE where instead of doing a static equivalent of a dynamic load and applying that particular load, and then you are going to export it, or you are going to just apply that particular static load and check. In static, it's going to pass, but as soon as the vehicle hits the road, a prototype mule is going to hit the road. As soon as it goes into a dip, the steering, you must have seen Ola pictures, the Ola electric pictures. It's very unfortunate, but it's happening. Why? Because it's purely an European vehicle. They may not have envisioned whether there will be too many bump holes or not as far as the Indian roads are concerned. So there are some cases where you are not having a steering column stiff enough and it just bends. They may improve, that's okay. So this is one way of looking at it. So let's go back to screen and then we will have a question and answer session. Only one or two scenarios I'll explain. This is very basic raw thoughts I came across my mind, and that's why I wanted to share with you. So I think it will be visible. One second. Yeah. Okay, so what is happening when we design anything? What do we design? We first select sometimes we first select the materials. Most of the time, to be very frank, first select the material. When I say select material, I really mean to say the basic metal, whether it is going to be a steel or aluminum or carbon fiber or whatever it is. So we select the basic metal. Then what do? We design section. We really don't design anything else. We do design sections. OK. So simple scenario of let's say ECER 66. What is ECE? Economic Commission of Europe. I'm giving you a lot of information. So if you want to write it down, just get your pen and paper out, type in PP in the chat box and just write it down. What is ECE? It is Economic Commission of Europe. So in ECER 66 standard, which is regulation 66, there is a bus rollover scenario. Bus rollover. So what happens? They take, I'll just explain this scenario. It's quite interesting and there are too many videos available on YouTube. So don't worry. What do? We have a platform. So consider this as a front view. This is a bus. This is front tires. There will be rear tires. And let's imagine this is the overall bus body. This is a front view. OK, this is ground and this height is 800 millimeter. Okay, I'm explaining you the entire what you say the regulation. OK, and what do? We have this as a pivot and there is going to be a tilt which is going to happen till this bus topples. That's a rollover scenario. It's a pure dynamic scenario. So what is going to happen in next step? This is the pivot and it's going to lift itself up, rotate itself up in this direction. And the bus is going to slide. It's going to slide off and it is going to roll over. Making sense, guys? This is going to roll over and it is going to impact this particular rigid floor. The floor should absorb no energy. And this particular scenario is what? It is pure dynamic scenario. So what is going to happen, guys? There is going to be superstructure. It is called as bus superstructure. So not the body, but the structure which is going to absorb a lot of energy. That superstructure will have this kind of, so if this is a side view, there will be this kind of structural supports. Okay, and these supports will be having some kind of a arrangement where you will have a trusses at the bottom. Okay, every design may be different, but there will be some kind of a stiffness being assigned at the extreme bottom. So what happens when it rolls over is these are the supports which need to have, these are the columns which need to have enough moment of inertia so that they hold up the entire structure. There should not be a breakage. There should not be a damage. What is important here? The important part is there will be a trapezoidal shape which is going to be placed inside the vehicle, and this is called as occupant zone. So no structure should get intruded inside this occupant zone. That's the regulation statement. So this superstructure, if it is weak, there is going to be too much of an intrusion in the passenger compartment and your bus will not be made allowed to go into the serial production. So this superstructure design depends on not just the static load. Of course, there will be a static load of the entire structure and the people sitting in it and etc. etc. That's just a pure static load calculation plus a factor of safety plus your luggage etc. All these things considered. But when you have a rollover scenario, it always depends on dynamic load as well. Okay, so we are discussing what do we design? We design a section. How do we design? We design a section by making use of available load cases. Are you with me, guys? Type in with you, WU, if you are with me. What do we design? We design a section for a given material. How do we design? We take into account various forces being generated by the regulatory standards. Okay, so you don't have any force input written here in this standard. There is no force input. It's just the physics of a drop, but it's going to generate tremendous amount of forces, and those forces you must be able to find out. So it's not possible to find out in a static way. It has to be given or taken into account in a dynamic scenario. Okay, with me, guys, everyone. Wow, thank you very much, guys. Thanks a lot. Okay, it makes sense. Perfect. Okay, this all makes sense. Now, when we have static load, dynamic load, section, the material, the type of, or I'll say where there is word dynamic load, but still I'll write it down. You have load direction, which is going to change as your regulation changes. So for one regulation, there will be one load direction. There will be another load direction for another regulation. So if it is a frontal impact, so let's take an example of a bus, electric bus, for example. So consider this as an entire bus, let's say 8-meter length, and you have a side. Let's imagine you have batteries in the floor. Okay, instead of on rooftop, you have batteries in the floor. There are companies who put batteries in the floor, so don't worry about it. For buses, I'm talking about. So if you have batteries in the floor, your CG will be down. You have a very stable structure. But if you have batteries at the top, you know what is going to happen in a rollover scenario or in a regular scenario. So you will have to add more mass at the bottom so that your CG still remains low. So if you have batteries in floor, the servicing and the other bit all becomes simpler, but it creates a problem for side crash. Okay, imagine a scenario where you have a car hitting. Okay. In this case, I'll just draw like this. This is a front view, and imagine this is a car. So for car, it is a side view, but for bus, it is a front view. Okay, and what is happening? This car is moving closer to the bus, and there are batteries here. So what is the sectional definition we need? We need a definition where this car hits at 50 kilometers per hour. And there is going to be a section which is going to prevent that car to hit the battery module. Okay. Now this is an entirely different situation as compared to the rollover stuff. Similarly, imagine you have this kind of a similar kind of a bus and you have a rear impact scenario and a frontal impact scenario. So if you have a bus at a length, and if imagine this is the car. This is a rear impact scenario. And there may be some important parts which you are going to put here. And if you haven't imagined a rear impact, it's quite possible that there will be a rear ending. Brakes fail, people don't see, or whatever happens. Or you apply an emergency brake as a bus driver, there will be a ramming. In a city scenario, it's quite possible. So if this vehicle is going to ram, this is going to be a section which is going to be an important section. Okay, so what is it that I want to convey to you guys is when I say design using CAE, okay, I'm just talking about bus situation. There will be electric 3-wheeler situation. There will be electric 2-wheeler situation. There will be forklift situation. Forget about what type of vehicle it is. You just focus on if you haven't considered all possible loads. Okay, and those possible loads may be directly given to you, direct available, or you will have to derive them using regulations. Quite possible. So you have to be having a perfect vision looking at this kind of a scenario where you will have direct available loads. You will have the loads which are derived from various regulations. CCR 66 is there. There is a pendulum impact for buses. There is rollover. There is side crash, frontal crash. There is RUPD, SUPD, FUPD, front underrun protection, side underrun protection, rear underrun protection. All these scenarios for commercial vehicles, passenger vehicles are supposed to be taken into account. And then what are you going to design? You are going to design a section for a given material. Now, if it happens that, okay, there is packaging limitations, I cannot fit for this material, I cannot fit a proper section, you will have to change the material. You may have to change the material, but it typically happens that what is it that we are designing? We are designing a section. When I say a section, I'm actually designing what? I'm designing section modulus for bending. Okay, typically we design section mode because in tension the material itself is so stiff most of the time. But when it comes to some kind of a load where load is little bit far away from the support, there will be a moment which is getting created, and that moment is going to cause a bending scenario where it is being associated with the entire structure and it's all going to collapse. Okay, so this is something which is not being taken into account when we design few important areas of a vehicle. And then there are failures, there will be customer driven failures or delays. The failures may not happen at a customer end because this will get rectified or this will get notified when there will be a proto build. So if a proto physically fails, you will be going back to drawing board and then you are going to do the same exercise again. So what is design using CAE, guys? Just to sum it up, and then we will open question and answers because we'll really finish it at 10 o'clock. Okay, we started sharp at 9, so we'll finish sharp at 10. So what is design using CAE, guys? It's very simple for me. Okay, what I have understood. Design using CAE is nothing but you create a basic section. Let's decide a section. Let's say a square section or a tubular section or an I section or a C section or something which is having a cross like what we see in our exhibition areas and aluminum extrusion. So you have a section in your mind, you decide that particular section and you do the first analysis without wasting too much time on CAD perfection. So what is design using CAE? Create a basic section, do a first analysis. Okay, first analysis, do the first analysis. This is second step. Without wasting too much of a time in developing a CAD, you just do basic CAD, basic put on it. Don't do a lot of connectivity and other bit. Define adhesives wherever there are adhesives, define welding, define bolting, define riveting, define screws, whatever you want to define. And that's the basic definition you should do and start analyzing as fast as possible. Don't waste too much time in creating a 3D CAD initially. The first analysis will give you a lot of information with regards to the overall scenario, overall what is happening in the first worst load case, and what you need to do, decide worst load case. What will be the worst load case where you will be able to see through that, okay, this is something which is going to be in the load path and it is going to fail. And that's what you want. You want a failure at the first go. And that's where you can do an optimum design, not the over design. OK, so you have third step as decide the worst load case, run the worst load case. So I'll just move it up and down. So first analysis, I'll just call it as let's say I'll rename it like this. First analysis. Yeah, I'll just decide worst load case. and do the first analysis. Okay, now it may happen that it may not be a dynamic case, but 99% of the time the worst load case will be a dynamic case. The static case may not be the worst case. Okay, and then what you can do? You can do a section or sectional force study. This is extremely important. So when you are going to start your simulation, you make sure that you have multiple sections defined on a particular, let's say column or a beam or whatever it is. And you are going to do a sectional force study, how exactly the load path definition is. This will give you a better idea in designing an organic section. A section which is designed for that particular load. Now it may be possible that because you are using it for the worst case scenario, you will have a design for that worst case scenario. It may be an over design for another case. Okay, or it may happen that it's an under design for another case. And there the combination of basics of engineering and the CAE tools and a CAD knowledge comes into picture, where all three departments must sit together, all three minds must sit together, and they have to figure out which will be the best section which we can put in the structure. Is this all making sense, guys? What is design using CAE? It's not a rocket science, but whatever I'm understanding when I'm doing it, it's relatable, right? Type in R if this is relatable. Type in R if this is relatable. Okay, so we are still doing basic strength of material. We are still doing basic design. We are still doing basic hand calculations, but we are not doing it at the first level. We are doing it at the second and third level, where we can improve fast, because we now know what is the load magnitude. Based on that load magnitude, we can keep and improve. We know the load path. We know the stress patterns. That is going to give you more of an idea of designing a better structure. So if you waste more time in doing CAD, it's going to be difficult for you guys to find out or to formulate or to finish your product in time. Okay, learning something, type in learning if you are learning something. L. Because we are going to open up for question and answers, I'll just stop sharing. Okay. And you can ask any question you have. Type in L if you are learning something. Great. Okay. So what I will do, I'll just enable for you all. Can I do it for everyone? I'm not sure whether I can unmute you at once. Allow mic. Allow mic. It's becoming one by one. Okay, 1 second. Can I select all of you? No. Okay, participants. Yeah, there you go. Allow mic for all attendees. Yeah, okay. There you go. So I have made it to all. Even I will allow camera for all attendees. So I would be happy to see your faces. Okay, so that's all from my side. What is design using CAE and the basic stuff? If you have any questions, just raise your hand and then start talking. I'll call your name once you raise your hand, so it will be less chaotic. Okay. Wait. I'm not able to hear you clearly. Is there someone who is not asking a question? Talking? 1 second. Let me mute the guy who is actually talking. Okay, yeah. Who raised hand? Yes, Harshil, go ahead. You can unmute and talk. Swapnil, you can do that. I'll watch your chat. Not an issue. Harshil, go ahead.
Okay. Is it audible?
Yeah, you are audible.
Okay. My question is from where we can get this standard for the 2-wheelers and 3-wheelers? for Indian drive conditions?
There are no standards. There are, see, I'll tell you. The crash standards are not applicable for electric two-wheelers and three-wheelers. They are only applicable for buses and passenger vehicles, which are cars. For three-wheelers, there is a standard which is more to do with the structural stability, but it's something which is not mandatory. So for when you go to AIS website or go to ARAI website, you'll get all the standards for electric two-wheelers and that's what. So Pnil, they are all ARAI standards, but they are not for crash or impact. They are more for speed, the light placement, indicator placement, luminous, battery safety, and other bit. Okay.
Okay. So if you want to do the simulation, then how to define this load case? Because
OEM has to understand the customer. They have to understand the customer. That means, is it a bike which is an adventure tourer? If it is an adventure tourer, what type of loads it is going to face? That's OEM's question. Nothing to do with ARAI.
Okay. Okay. Thank you.
Yeah. Good. Chandra Kumar, go ahead. You can unmute and talk, Chandra Kumar. You are not audible. You can unmute. Can you? Yeah. Now you are on mute.
Hello.
You can type in. Yeah. Yes. Now I can hear you. Go ahead.
Yeah. Actually, somebody is asking, I think, load conditions and standards. Okay, so here there won't be any load conditions. Okay, yeah. So I worked for 2 years completely in R&D electrical vehicles. So here, as a OEM, as you mentioned, yes, we have to build our load conditions.
Correct.
Because already in the market there are Hero Motors, Bajaj, they have their benchmark data. So that benchmark data may not be available for all startup companies.
That they will make sure that it's not available because that's their hard-earned.
Okay, so we have to establish our load benchmark data, static scenario, dynamic scenario. Even though crash analysis is not there, first we have to do the static, and then we have to bring the dynamic condition to the static condition. We have to have CG calculations and free body diagrams. So all these things we did during the concept design.
Correct.
So as you mentioned, probably each section difficult to take the load condition because there will be multiple load conditions will be there. We cannot say one is subject to bending or maybe something. Okay, so maybe probably you have to understand the load path and we have to find the critical one, and that one we have to analyze, whatever maybe the load cases, we establish it.
Yep.
That is one scenario. And second one, as you mentioned, AIS, yes, they have not given completely load cases, but they have given the regulatory parts actually. So
yeah, AIS is more of a regulation, more of a size, dimension, what is the power wattage, and what is the luminous intensity for the brightness of the headlights, tail lamps, positioning, etc.
So they will give you regulatory parts. So all these regulatory parts, we have to qualify specified. Suppose if you take like two-wheeler, we are new to the market actually. Our means the company. So two-wheeler, we identified all the regulatory parts from the AIS standards. There are particular standards are there for two-wheeler and four-wheeler. It's open source. We can download and we understand also from the ARI website. The standards are AIS standards.
Yes. Okay, so absolutely.
It's like even materials also, if you see, pretty much like people use the more or like standard materials only. So I mean, like people may not do, people do invention much on material and that's because already in the market standard sizes, standard materials already available, proved. If like database is available with us, something if you do from the scratch, very scratch, then you are right. Maybe you may take the vehicle and we disassemble and we go for component level testing, and we may investigate the material reverse engineering, but very few people are doing that reverse engineering.
Yep, you're right. Thanks a lot, Chandra Kumar. Thanks for your insights. I'm very glad that you're working in this exciting domain and you're sharing with us.
Thank you very much.
Yeah,
It's like, here the situation is what we observe. Like, there are some vehicles. I do not want to mention the vehicle name. People are failing in the structure. Actually, there is one vehicle where we put scooter, where we put our foot legs. Like there some breakage happened. So in the market already many vehicles are there. Lot of research was happened. We are good in automotive, but failure in structures is a bad situation for us. If we fail in thermal management, if we fail it on the controller or maybe the motor or maybe the integration, we are okay because it is tolerable. If you see the history, I read during my investigation around 200 to 300 articles I read because we have to establish some data. Journals. So journals will give you, like when anybody is working startup, I can suggest simply taking data from client or maybe somebody, just why it came, we have to question and we have to realize the data, how it came actually. It's not something like, just take and give in FEA, as you mentioned, that is correct. FEA is a tool, but it just gives some input, it will give output. But why that one came? And so if you realize like vehicle dynamics, I hope people will enjoy, things when they start up companies.
Correct. Yep.
That is one.
Thanks. Let's move to the new question. Thank you very much. Yeah, Sumit is having a question. Bharat New Vehicle Safety Assessment Program will cover three-wheeler crash norms. No, I don't think so. It's still under consideration, but it's really not possible to have three-wheelers having a huge structure in front of them which can absorb a crash load. Okay, so you need a car-like structure. You need a structure where passenger is not directly sitting in front of a crash situation. Okay, so it's not going to happen. Yeah, Ramesh, yes, you are right. It includes braking test for electric three-wheelers. But again, as I said, the braking test is more to do with the distance, less to do with what happens to the structure. You must be putting your vehicle to hold after some time. That's something which is important. Okay, so good. That's nice. Fine. Any other question, guys? Hope you enjoyed the session. I will be anyway uploading this on YouTube, on LinkedIn. Yep. Dipankar, go ahead. You can unmute and talk.
Good evening, sir.
Very good evening.
Actually, sir, I'm a final year student from NIT Warangal. I messaged you on LinkedIn. So, sir, my question is for my major project, I took the topic of crash worthiness analysis for passenger vehicles. And I was reading various research papers from International Journal of Crashworthiness, and what I concluded that what the research paper says that they took some CAD models of previous vehicles like Dodge Neon. It was a Ford model from 1950 to 1960, and they ran a crash worthiness analysis by changing the material or by optimizing the designs of A-pillar and crash box. So, I want you to guide me, like if I want to do my major project in this field. So how should I proceed now further? Like, should I make a new monocoque chassis, or should I download some existing monocoque chassis and run a crash analysis, then see what it is?
I think we will have to connect on a one-to-one in a one-to-one mode, because it's a very vague question, to be very frank, Dipankar. The point is, are you just fascinated to do the crash analysis, or you really want to give some or the other input to the industry that, okay, this is something going in a wrong direction maybe, and I think this is the right way to move forward. So the why you want to do this particular project of crashworthiness is actually going to make more sense, or it will give you a better answer.
Okay, sir.
Okay. So see, there are two things. One is you have a problem statement from the industry, and you are going to have that particular problem getting solved. That's one way of looking at your project. The other way is you are doing your project because you want to enter into that particular field. You may not be an expert right now, but you really want
I'm not
to
an expert. Yes, sir.
Yeah.
Yes,
so
sir.
You want to enter into crashworthiness analysis, and that's why you want to have full 1 year dedicated on crashworthiness studies, so that you can showcase and can enter into the crash studies.
Yes, sir.
So this is something which is very important, which is extremely valuable for me. Your own answer why you want to do it is very important. See, doing some sectional changes in the existing vehicle, I will not call
Yes,
it
sir.
as an MTech level project, to be very frank.
Yes, sir. Yes, sir. Yes,
Okay,
sir.
so I'll
Totally
just
agree.
call it as a project for publishing it in some journals, because you are not really going to
Yes,
do a
sir.
physical test of that
Yes, sir.
particular
Yes, sir.
section. You are not going to build a
Yes, sir.
physical model of it,
Yes, sir.
and that's not going to cause or create any kind of a buzz in the industry or in your own mind. You will be learning
Yes, sir.
LSDYNA that you can anyway learn with me, and that doesn't need any kind of an MTech project to be done here. So what MTech project
Okay.
we did with some of our students, I'll tell you. One of the MTech project was about thumbs dummy. Thumbs is total human model for safety, which is a Toyota dummy. So we did a
Okay.
comparison study of FTSS thumbs and LSTC dummy with the existing vehicle. Now that is something where you are going to add more value to the industry, because industry is not using thumbs dummy a lot. So you may have a comparison study of these three dummies and injury criteria as a head impact and a chest injury and other bit, and then you can have your own understanding of LSDYNA as well. So this is one way of looking at it. The second way is you can have many different things which are moving forward with regards to composites or welding techniques and other bits. So it's up to you how you choose it. Okay. So let's get
Sir.
connected. Anyway, you are connected with
Yes,
me
sir.
on
Yes, sir.
LinkedIn. So let's see that. Okay.
Yes, sir.
Yes. So so people are asking my contact. Okay, guys, here you go. 9881732144. I'm pretty accessible everywhere on LinkedIn. Bit.ly. This is my LinkedIn profile. Nachiket Phadke. So just save these two chats. I think it will be easy. Suraj, please share your contact, as I want to have a word regarding training in CAE. I would also like to know your organization institute name. It is LNO. I explained you earlier, but it is LNO Engineering Learning Center, which is my training company, and I do training there. As I said, there is no other employee. Yeah, this is what you can search for. Not a problem. Okay. And best way is to get connected with me on LinkedIn. Okay, there are some raised hands. Samuel, go ahead.
Hello, can you hear me?
Yes, Samuel, go ahead.
Okay,
I can hear
lovely.
you.
So I recently completed a master's degree in automotive and motorsports in London, and my dissertation was on crashworthiness optimization using 3D printing and numerical modeling. I developed a concept crash structure, which is a modular concept. So it's neither passive nor is it active. It's a hybrid crash structure, and the purpose is that it can be integrated into every vehicle in the world, whether it's electric or it's petrol, as long as it has a chassis.
Wow. Okay.
I ran FE analysis for crashworthiness using LSDYNA, and my prediction was that my structure can absorb about 61 kilojoule of energy during a
Wow.
frontal impact. Yeah, during a frontal impact.
Great.
So I concluded my dissertation, obviously had good ratings and A-star and all that. But right now, I'm in a state where I'm trying to progress with my design. It's quite difficult talking to anyone about it because I have to create a patent, secure it, and all that. So what I've done right now is create an NDA, a non-disclosure agreement, and I'm working on trademarking the name because it has a name that accompanies the design itself. So I'm trying to trademark the name first of all, which I'm in the process of doing. Obviously, the patent is quite expensive, so it's going to take a while for me to be able to get there. But I have this crazy idea that I believe my professor, obviously I know he's well experienced in that area, and he also believes that it has the potential to work in every case. Basically, my studies prove that it could increase the survivability rate during a frontal impact by over 20%. So
Oh, wow.
yeah, so I I want to take my design to the next level. I want to do a physical analysis on it. I just it's going to take time with the process I'm taking by securing it, getting the patent and all that. Do you have any advice, or do you have any any experience, any of your experience for me that I could use to further on this?
I think yes, we are doing a lot of studies like that. Of course, not my studies.
Yeah.
We did supported some of the US customers with regards to their neck injury related devices. They were already patented, but then we developed the entire patent into a product. So your case is a little different. You already have a product and you are going into that particular thing. So Samuel, my simple suggestion is get connected with me over LinkedIn. I have
Yeah.
posted a link of my LinkedIn profile.
Yeah.
You can just connect with me,
Okay.
and let's try to explore. I'll be very happy to support you, but let's understand what are my limitations and what is it that you are expecting, whether we
Okay.
really are in a match or not. And
Okay.
I'll be happy to sign an NDA as well. My company will be happy to do that. We are extremely ethical when it comes to, or we are very, what you can say, customer focused when it comes to sharing of any of the data. So that's something which I will be taking it very seriously. So let's get connected. It will be a very good avenue on LinkedIn to have a connection. Not a problem.
Yeah. Thank you very much.
Yep.
Thank you.
Thanks, Samuel. Thanks
Yes,
for
bye.
attending.
Yes, sir.
Yeah, Napoleon, go ahead. You there?
Sir,
Yep, I can hear you.
uh, sir, I'm much grateful for attending the meeting, sir, getting so much information. As a fresher,
Glad.
as a fresher, I'm just completed B automobile engineering, sir. I'm much interested in knowing about CAE. In college
Okay.
studies, I just learned about basics about strength of materials, design of mechanics, next the MOM, machines of mechanics. So I don't know why just reading the data alone. How do I need to apply that, and how I need to analyze that? I don't know,
Okay.
sir.
Okay.
Now regarding this, because this webinar gives me the confidence that these are things to be understand apart from the studies. Just I got
Yeah.
ideas. Uh,
Yeah. See, it's not apart from studies, to be very frank. I still believe that the education which we get in the engineering is very good at the theory part, but
yes,
the practical application of that theory is not discussed.
yes, sir.
So we solve a lot of complex problems in mathematics and in some various different beams, but we really don't see them in real life. Where is this kind of a beam which is there, which is having UDL plus a point load plus some kind of a uniformly varying load? Where is this? So that's the missing link which I'll be happy to bridge. So Napoleon, do one thing. You can just visit my
Sir.
Illinois Engineering Learning Center YouTube channel.
Okay, sir.
There are many videos, almost 70 videos about CAE and crashworthiness and importance of it and how to enter. So
Mm.
that particular thing will give you a better idea whether you are really good at it or really good to enter into this field or not. And then, as I said, you are always welcome to connect with me on LinkedIn or on my mobile phone. Not a problem. Okay.
Okay, thank you, sir.
Yeah. Good. Okay. It's wow, 10 minutes past 10. So we'll call it a day, guys. Thanks a lot. I'm really grateful to you all. Thank you very much. You came, you attended peacefully and silently. You attended my words, and it's been a pleasure to host you. So let's get connected on LinkedIn. I have already put in my chat box my phone number. You can connect me on WhatsApp as well. I have a single number, and you can just drop me a message on LinkedIn as well. Okay. See you guys. Have a good night. Bye.
Yeah, bye. Good night. Thank you. Bye.
Thank you very much. See you. Bye.